Hi, in this video I'm going to talk about typecasting in C++. There are two main types for casting in C++. The first one is implicit conversion. The second one is explicit conversion. Explicit conversion can be done in many ways. First one is functional and C-like casting. Then we have static casting. Then we have dynamic casting, then constant casting, then reinterpret casting. We will talk about all of these way of casting. Typecasting definition. So converting an expression of a given type into another type is known as a typecasting. So for example, if I want to convert integer into a type long integer, this is called casting. It's conversion one type to another type. The first type of casting is implicit conversion. Implicit conversions do not require any operator. They are automatically performed when value is copied to a compatible type. So here we have an example of implicit conversion inside this main function. In this line we declare a variable a of type long integer and we assign it a value. Then we are trying to casting a into b. b is of type short. So we are saying we need the value a to be in b, which is of type short, and this is implicitly done. And so the value p will have the value a if it has enough bytes. In this case, 2. b is of type short, so then it has 2 bytes, and the long integer has 8 bytes, and so the 2 bytes can afford this value. So both a and b now has the same value, and so you have to be careful when implicit conversion is done, because if you try to increase this value, for example, into if you put 68 instead of 66, you will see different value for p, because in that case you exceed the limit of the 2 bytes. You have to take this into consideration when implicit conversion is done, so that the value might change, or the sign also might change. This is another example for implicit conversion. Here we are trying to cast float into an integer. So 5.9, cast it to an integer, the value will be 5. Here I'm trying to cast integer to boolean. So how can this be done? Any value for integer not equal to 0 will be casted to true value. True is 1, and when the integer equals 0, it will be casted to false, boolean false, which equals 0. So here we have e equal minus 5, which is not 0, then it will be casted to true, and true means 1. This is why f of type boolean equal 1. In this right side we have another example. Here we have simply class A, and this class A in the constructor take integer, and if we try to say this a1 equal 1, this is completely correct, because implicit conversion or implicit casting will happen since we have this constructor that take an integer in its parameter, it's considered as converting constructor, and in this case 1 can be converted into an object of type A. In case I want to avoid this kind of implicit conversion in the constructor, I have to use explicit keyword. In this case, you say implicit conversion from integer to p type is not allowable. As you see here, p1 equal 1, this will throw an exception, and as you can see here, errors. Copy initialization does not consider p, and conversion from integer to non-scalar type p requested. Now we will talk about explicit conversion. We already talked about implicit conversion. Now we'll talk about explicit conversion. The first casting type of explicit conversion is functional and C-like casting. Many conversions, especially those that imply a different interpretation of the value, require an explicit conversion. Explicit type conversion, functional, and C casting. Here we have an example, the main function. So we have short integer k equal 1, integer L. So I want to cast the short into an integer. So even though this can happen implicitly, we can use the C-like casting like this. So I'm saying cast this k into type integer so that I can assign it to L, which is of type integer. Also here there is functional notation casting. It's look like a function call, but it's casting. So L is of type integer and k is of type short, say, and I want to cast k into an L. In this case I say I want to change the type of k, which is short, into an integer, so that I want to assign it to L. And remember, this can be happen implicitly, so no need for this, but this is more clear if we use the explicit conversion. Here is another example. So I have class A, which take integer in its constructor. It has two variables. I'm declaring here a pointer A of type A, and this pointer points to an object, and I'm passing the value 5 to its constructor. So if I try to declare P object pointer of type P and assigned A to it, this operation is rejected, and it cannot happen implicitly, because A and B are completely different classes. So the implicit conversion will not work. In this case I need explicit conversion. So here we say traditional explicit type castings allows to convert any pointer into any other pointer type independently of the types they point to. The subsequent call to member will produce either a runtime error or an unexpected result. So here we are casting A of type A star into P star pointer, which is completely different type, and so trying to access PLV is undefined results. So you have to be careful when changing or casting pointer to another type of pointer. The second type of explicit conversion is static cast. Static cast, it is a compile time cast, so it happens in the compile time. It does things like implicit conversion between type like float to integer, so we can use it the same way as we did for C style and functional type. We can use instead the static cast, and the static cast is better because it has control conversion between pointer. So if you try to cast pointer to an object to another pointer type which is of different type, so in static cast it will give an error at the compile time. This is why it's better than the C style conversion between pointer to related a class from a base to its derived, and of course from derived to base. So in case of inheritance, you can use the static cast to convert the pointer from parent to child, or from child or from derived to base class. There is no runtime checks, it's only on compile time. Should be used if you know what you refer to an object of specific type, and thus a runtime check would be unnecessary. As we said, like in the static cast, only at compile time the check will happen. If you try to cast pointer of specific type to another pointer of completely different type, it will give you an error. But also you have to be careful when there is polymorphism and you try to cast parent pointer that points to derived object. If you do it with if you do the casting to another class or another object that inherit from the parent class, but it's different type, so it will be successfully done. So at the compile time it will pass it, but runtime there is no check, and so the behavior is undefined. We will see that by example. Use static cast instead of C style cast, it's more clear and readable. Static cast, this is how can we use static cast with parentheses, with these brackets, and you define here the new type and here the expression. Here's an example. On the left side we have a parent class called animal, and this animal, this is the constructor, and here we have virtual function to define like polymorphism. This function is just printing, just print I am an animal, and here we have two classes that inherit from the parent class. First one is dog, the second class is cat, and for class dog it overrides the print function and it print dog, and it has specific method called sayWolf, print wolf, and for the same for the cat, it overrides the print function and says I am a cat, and it has specific method called sayMeow, print meow. Here we have different example, class A and class B. These are separated from the above classes, and we will see how to use them in this main function here in the right. So static cast. The first example is as we did in the implicit and C-style conversion. Here we have a variable of type float, which equal 5.5. I'm trying to casting it using static cast to an integer type. So simple, I use static cast, and I need to, the target type is integer, and I put the value, the variable name is f, which is of float type. In this case I will equal 5. Here I'm defining a pointer to class A, and if I try to do static cast to type P star, this will throw an error. It will say invalid static cast from type A star to type B star. And so static cast, unlike the C style or functional cast, there is a check happens here, because A and B are completely different classes, and I'm trying to cast A star to P star, an error will be thrown, and this is an advantage for static cast over the C style casting, because there is no such checking. The second example here, I'm defining animal pointer 1, which points to an object of type cat. So parent pointer points to a derived or a child object, and it's polymorphic class because we declared it as a virtual. So when I call print, it will print the function. It will call the function inside the child class or the child object. This is how the polymorphism works. And here you see it's printing I am a cat. If I try to access say meow, this method from ptr1 of type animal star, and in the parent class we don't have this method, so an exception will be thrown, or an error will be thrown, which is class animal has no member say meow. This is at compile time, so the compilation will fail. How can I fix it? I need to cast the animal star pointer into child or cat pointer. So here I'm trying to do downward casting cat star. So I use static cast, and the new type is cat star and pointer 1, which is of type animal star. So I'm casting animal star into cat star, and now it's safe to call say meow because the pointer cat is of type derived or cat star. So meow will be printed. Now here there's another example. I'm declaring again animal pointer, which is parent pointer to object of type dog. Now if I try to cast this pointer into cat star, like the derived class cat, this down casting will fail, because, or it will not fail, actually it will pass, but it will give different or undefined behavior. The reason for that is that this pointer animal points to type dog. So if I'm trying to cast it to cat, which is different type, compilation at the compile time it will not throw an error because both because both classes cat and dog inherit from the animal, and so the behavior will be undefined. So here, for example, after the casting, it's I'm dog, and you can access the same meow, and it will print meow. So this is undefined behavior. So you have to be careful when casting parent class into child class. You should be sure of the type of the pointers. For example, here I know it's ptr1 points to new cat, so it's safe to cast it to cat pointer, while here I know it's in new ptr2 it's point to a dog object, so I can't cast it to cat pointer. Static pointer cast. So static pointer cast used instead of static cast when you deal with shared pointer. Here we have the same classes in the previous slides, and instead of normal pointer I'm defining shared pointer, and trying to use static cast with shared pointer. So if I'm trying to cast shared pointer or this animal parent, even though if it point to a cat object, I'm trying to cast it to shared pointer of cat. This will not compile. It will give an error because shared pointer cat itself is not a derived class from shared pointer animal, while cat is a derived class from animal. So in this case, when you deal with shared pointer, instead of using static cast, use static pointer cast, and you just give it the type of the class, in this case cat, and you can access its method, pointer methods safely. The other type of explicit conversion is dynamic cast. This is a runtime cast. It's not happening in the compilation time like the static cast. It happens during runtime. It is useful especially when combined with polymorphic class. So when there is polymorphism and you want to cast and there is parent pointer point to a derived or a child object, and you have to cast it, so you have to use the dynamic cast instead of static cast, unless you know exactly what's the type of the pointer, the parent pointer, the type of the object that the parent pointer point to. When a class is polymorphic, dynamic cast perform a special checking during runtime to ensure that the expression yields a valid complete object of the requested class. If it's valid, return a pointer, otherwise it returns null. This is very important. So when you do a dynamic cast from the parent pointer into the child, let's say this is correct conversion, then a pointer of the derived class will return from the casting, while if it's wrong, a null pointer will be returned. Because of this checking, the dynamic cast has less performance than static cast. So if you know the types of pointer, use static cast, otherwise use the dynamic cast. The same as static cast. This is how can I use dynamic cast. New type and expression. On the left side we have the same example before, animal, virtual, dog and cat, and we have the same two classes here. Here we'll see an example how to do dynamic cast. First of all, I declare pointer of type A that points to class to an object of type A, capital. And if I try to do dynamic cast to type P star, error, cannot dynamic cast A of type class A star to type class P star. Source is not polymorphic. So here we have two different kind of classes. They are completely different. There is no inheritance and they are not polymorphic. In that case, if I try to do dynamic cast in the compile time, an error will be thrown because it's clear there is no polymorphism. Here I declare a pointer of type parent animal that points to a cat object. So ptr print will print cat. Now if I try to access the say meow, you can't do that because say meow is in the child object. You can't, there is no method here called say meow. So in this case you have to cast or convert the type of animal star into cat star cat, cat star cat equal a new cat. So here I'm defining or I'm declaring a new object of derived class called cat, and animal star animal. If I try to do upward casting from this derived class, it will successfully using dynamic cast and also using static cast. Also this is safe. So in this case I know casting from down to or from child to parent, I would recommend to use the static cast because it's faster. So as we said, for dynamic cast happen during runtime. And how can I know if it's successful or not? Through the return pointer, animal star animal, and if the return value is not null pointer, it means the casting happens successfully, while if it's failed, it will say the null pointer will be null. In this case it's safe to convert cat star into animal star, and so dynamic cast from cat star to animal star succeeded. Here, and if I try to do downwards casting, cat star pointer 1. So pointer 1, remember it's of type animal, which points to a cat object. So in this case downwards casting from animal star to cat star is okay using dynamic cast, and you can check that by checking the value of the pointer if it's null or not. So in this case it's passed. So dynamic cast from parent to cat star successful. Here I'm defining parent or animal star to point to object of type dog. If I'm trying to use dynamic cast this pointer into a cat star, this should fail because cat is different type from because pointer 2 is pointing to a dog, not to a cat. So this operation is this pointer will be after this the dynamic cast, the value of the pointer will be equal to null, and so this will be executed and dynamic cast from animal to cat fail. So to summarize this, you can do from child dynamic cast from child to parent, and as we saw here, and you can do downward casting from parent to child if the types are matching. So here it points to cat, so you can do dynamic cast to cat. And after casting, you can check if the casting happens successfully by checking the pointer value if it's null or not. Here is another example how can I use dynamic cast. These are the same classes, animal and animal, dog and cat. Here in the main function, what I'm trying to do is for loop 5 iteration, get random value. So this is just to produce random value, you don't have to worry about it. And here I'm declaring parent or animal start pointer, which is null. Inside the for loop, randomly I get the boolean if true or not. If it's true, I'll assign a cat object into the pointer. Otherwise, I'll create the dog object and assign it to the pointer. Then we have function call animal. This take animal star pointer, the pointer of type animal, and here I have to know if I need to cast it to a cat or to a dog. So I used this method type ID of for the object. This is how I dereference the object. So if the type ID equal the type ID of cat, then this pointer points to a cat. Then I will do the dynamic cast to a cat pointer. Otherwise it's a dog, and so I'll do dynamic cast to dog pointer, and I'll call here the method semio, and I'll call here say off. And so here if I call animal and pass it the pointer, the proper methods will and the proper casting will be done. As you can see here, randomly I created a dog, and this is the proper method called. Here the same, and here cat generated, so meow. So this means the casting happened successfully. And this shows another example how can I use dynamic cast properly during runtime. Dynamic pointer cast. So in case I want to deal with or you are using shared pointer instead of raw pointers, you have to use dynamic pointer cast instead of dynamic cast. This is the last example, and here instead of normal pointer we have shared pointer, and also you see the function take shared pointer. So in this case you have to use dynamic pointer cast, because dynamic cast will not work. it will throw an error in the compilation time. Constant cast. This is a new type of explicit conversion used to cast away, remove constness. This is the use for constant cast. So here is an example. I have variable I, and this is constant reference to I, and I want to change the value through this reference, so I can't because it's constant, and this is why I do const cast int reference. In this case I remove the const from this from I reference, and so this will return int ref, and so that I can access the value and assign new value to it for. After that, if I check the value for I, it will be 4. Here is another example. I have constant pointer. Constant pointer points to an object of type integer with value 5. In this case I can't change the value using the dereferences of the pointer, and I can't even pass it to a function of type integer stars. If I want to pass this to a to the function, it will throw an error, invalid conversion from constant pointer to normal pointer. So in this case I can use constant cast, and here I put in star, it will remove the constant, and so it's valid to pass it to the function. The same case, if you deal with the shared pointer, you have to use constant pointer cast instead of constant cast. This is an example. We have shared pointer, point to an object and the value is 5, but here we have constant, so the pointer of type constant, and so you can't change the value of a through the referencing conversion from shared pointer. And if I try to create a new pointer p equal a, this is not allowed because p is of type integer, shared pointer integer, while p is of type shared pointer const integer, and this operation will be rejected. So in order to do that, you have to remove the constant from the shared pointer a through the casting, through using constant pointer cast, and then you safely can assign it to p, which has no constant, and you can easily change the value of p, which will be reflected to a. This is why now a or the object that pointed by a is changed. Reinterpret cast is the last type of explicit casting in C++. Reinterpret cast convert any pointer type to any other pointer type, even if unrelated classes. The operation result is a simple binary copy of the value from one pointer to the other. Reinterpret cast is a very special and dangerous type of casting operator. It is suggested not use it unless required. It is used when we want to work with pets. So reinterpret cast is, let's say we have a pointer point to an object, this pointer of any type, and using reinterpret cast you can change the pointer type to any type and make it point to the same location. This is very risky because A and B are completely different object, and reinterpret cast still can do this casting, but it's useful in some cases, like if I want to deal with the pets and I want to see if the implementation in the machine is Little Indian or Big India. Or here we have another example, create hash function that take void start parameter, and I use reinterpret cast to cast this pointer into type unsigned integer, and after I do that I use XOR to do the hashing, so that mostly unique values will be generated from this function. So this is an example of how to use reinterpret cast, but in general it's very rarely used. Let's summarize casting in C++, or these are useful advices to follow in coding using casting. First of all, use casting rather than implicit casting. It will make the code more clear. Use static cast instead of C-style cast, as it checks for potential errors, and so it's more safe. As we said, the C-style, you can change cast pointer of some object or some class to different type, and it will not throw an error at the compile time, while the static cast is more safe because it will tell you there is wrong casting. Static cast has better performance than dynamic cast because there is no check happens during runtime. Static cast works on the check only happens on the compilation time. So if you know the types of pointers, while in the compilation time use static cast instead of dynamic cast. Use dynamic cast when casting parent to child pointer in polymorphic classes, and you can know after the dynamic cast if it successfully happened by checking the return pointer. If it's not null, it means it's casted correctly, otherwise it's failed. Use static pointer cast instead of static cast, and use dynamic pointer cast instead of dynamic cast when casting shared pointer. So when you deal with the shared pointer, you have to use these for static and dynamic cast. Thank you for watching.